Hi, welcome to lesson 3.3, Proofs with Parallel Lines. Now, in the previous lesson, we learned what happens when you have a set of parallel lines cut by a transversal. You had four different angle relationships that 3 out of 4 were congruent and only one of them was supplementary. So today we're going to be working our way backwards, meaning that instead of the conditional statement, we're going to be looking at its converse. Now, I'm not going to be writing each one of the sentences. I'm going to be showing you guys the diagram that explains what this is talking about. So here on page 76, you see the diagram where if you have a set of parallel lines right here cut by a transversal, then you have the pair of corresponding angles that are congruent. The converse of that works backwards, meaning that if you have a set of lines, notice I said a set of lines, not parallel lines. Okay, if you have a set of lines cut by a transversal, okay, if it so happens that the corresponding angles, because two angles can be corresponding and not necessarily be congruent like you saw in lesson 3.1. So if the set of if the set of lines are cut by a transversal, we're going to call that transversal T. Okay, I'm going to call this P and Q. Okay, so if the two lines are going to be cut by a transversal and the corresponding angles are going to be congruent, then that is going to imply that the lines are going to be parallel. So try to understand what we're trying to do here. We're going backwards. In the original theorems, you had if these are parallel, then these angles are congruent. In the converse, if these angles are congruent, that implies that these are going to be parallel. So the same thing is going to happen with these over here. If you have two lines cut by a transversal and you have a pair of alternate interior angles that are congruent, that's going to imply that these lines are going to be parallel. Okay? So if these are congruent, then these lines are parallel. So all we're doing today is proving that lines are parallel by using the converse of these theorems. And we're going to go over these in just a bit. Now, similarly, if you have a set of lines called P and Q cut by a transversal and the pair of alternate exterior angles are congruent, that is going to imply that the lines are going to be parallel. So it's working pretty much backwards. Okay, turn to page 76. Now here, if you have a set of lines that we're going to call P and Q, and you have a line, a transversal, which we're going to call that T. The lines are not always going to be called P and Q and T. I mean, they could literally be called anything. Okay. If these two angles right here are indeed supplementary, okay, so if these are supplementary, then that will imply that these two lines are going to be parallel. So in this case, these two angles, they must be supplementary. Okay, so let's go ahead and we're going to look at those theorems in just a second, because what we're going to do next is we are actually going to do a construction. So pause the video and make sure that you guys have your compass and your protractor. You're going to need this for the next part of the activity. Okay, so we're going to move on to page 78. And on page 78, we're going to do a construction called constructing a set of parallel lines. So we're going to be constructing a set of parallel lines pretty much. So what we're going to do is the following. Okay, we're going to construct line P parallel to line Q. Okay, so in order to do this, the very first thing you need to do is just simply draw a line. Now, whether you call this one P or Q, it honestly does not matter. I'm going to call it a Q. Now, in order to construct the parallel lines, we need to construct a set of corresponding angles or alternate interior angles or alternate exterior angles. There's literally like 3 different ways to do this, okay? But we're going to focus on the corresponding angles. Now, in order to do that, I need a transversal. So I'm going to create a transversal. Now, it doesn't really matter at what angle you create this line. You don't necessarily have to do like a right angle. But if you just do an angle about this much or so. Okay, about that much. Now, how far apart do you want these lines? It's really up to you. Don't make them too close to each other because it's going to be a little bit difficult for you to do the construction. So I'd say eyeball it kind of around there. Okay, so this is the point where my transversal is going to hit that parallel line that I'm going to do. So what I'm going to do is I am going to copy this angle that you see right there. Okay, so let me show you guys how we're going to do that. I'm going to turn the paper around, making the angle face away from me. Okay, I'm going to put the metal piece. Let me fix my compass. It's a little. Okay, so you're going to put the metal piece right here. Okay, everybody see that? Put it right there. And you're going to lean the pencil forward and move the paper, not the compass. So make sure you're doing this on a table, otherwise it's not going to work. So lean the paper forward, lean the compass forward and create an arc such that it's going to hit both this transversal and line Q. Okay, kind of like that. Now leave the compass the same way. Put your metal piece on the period, on the point, and create an arc such that the arc it's about 1/3 of a circle. You just got to make sure that that arc goes below that point. Now, in the next step, we are going to measure the distance from here to here. Now, I can look for an alternative video on how to create this angle. How to copy, not how to copy, but how to construct a parallel line. And I'll try to post it in the description. So measure from here to here. Okay, measure from here to there. Let me see, my hand's in the way. So measure it from here to here. Okay, and then turn the compass around and put the metal piece right on this intersection right there. Okay, right on that intersection. And when you do that, gently draw a little line like this, such that there's an intersection right there. Okay. Now, it's not going to be perfect, guys. Okay, so you're going to go ahead and line up your point and that intersection and create the line. So what I just did is I just made a copy of this angle right here and this one right here. And these just happen to be corresponding angles and they're congruent. So that will imply that these two lines are going to be parallel. Okay, so we just did P parallel to Q. Okay, and that is our construction. Now, let's go ahead and look at the theorems that we are going to be applying today. The first theorem is at the bottom of page 78. Problem 1 is going to go there. Okay, so it says if two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are going to be parallel. So if you have a set of lines cut by a transversal and the corresponding angles are congruent, that will imply that these two lines are parallel. Okay, so remember, our goal is to prove that lines are parallel. All right, next page. On the next page, you have the alternate interior angle converse. That states that if two lines are cut by a transversal, so the alternate interior angles are congruent, then the lines are going to be parallel. So we're doing the converse, remember. The alternate exterior angle says that if two lines are cut by a transversal, so the alternate exterior angles are congruent, then the lines are going to be parallel. And the next one is the consecutive interior angle converse. If two lines are cut by a transversal, so the consecutive interior angles are supplementary, then the lines are parallel. So if angle 3 and 5 are supplementary, then the lines are going to be parallel. So these four theorems, they're the converse of the theorems from last lesson. And then this one's not the converse of anything, but it's a very important theorem. It states that if two lines are parallel to the same line, then they're parallel to each other. So if this line is parallel to this one, and this one is parallel to this one, then these two right here are going to be parallel to each other. It's called the transitive property of parallel lines. Now don't forget, that's where problems 2, 3, and 4 are going to go. Okay? All right, let's go ahead and begin our examples. Okay, here is example number 1. Now it says, find the value of x that makes these two lines parallel. Now, this is going to look very similar to what we did yesterday. I mean, not yesterday, but like when we did the last lesson. So we have to assume that they're parallel so that we can determine what the value of x has to be. So if these are parallel, then that means that these two angle pairs are going to be congruent because they happen to be corresponding. So if they are indeed congruent, that means their measurements are the same. Okay, so their relationship is that they're corresponding, so that is why we equal them, because they're congruent. So our goal is to solve for x. So 3x plus 5 equals 65. You minus 5, you minus 5. 3x equals 60. And when you divide it by 3 on both sides, x is going to be 20. Now, make sure you're paying attention to the question, because if they want you to go back and figure out the angle measurement, then you have to go back and plug it in. But in this case, they don't. So if x equals 20, that angle right there is going to be 65. And if both these two are congruent, that will imply that m is parallel to n. So that is example number 1. Here's example number 2. It says, prove that if two lines are cut by a transversal, so the alternate interior angles are congruent, then the lines are parallel. So what we're going to need to do is we're going to have to prove that if the alternate interior angles are congruent, then the lines are going to be parallel. So first off, we need a diagram. Let's go ahead and draw one. So if I have two lines, now notice they look parallel, but I have not proven that they are. So you have two lines cut by a transversal. My goal is to prove that angle 4 and angle 5 right here are going to be congruent. Now I need another angle to kind of help me out here. And I'm going to use the same strategy that I used in one of the problems in the last lesson. So what is given to me in this case is that if angle 4 is congruent to angle 5, then I need to prove that the lines are parallel. So I'm going to call these lines G and H. So I have to prove that G is parallel to H. Okay? So we're going to set up our two columns. So the very first thing is that angle 4 is congruent to angle 5. That is given. Now here's the thing. Angle 4 is congruent to angle 1. Okay? So the reason why is because they happen to be vertical angles. Okay, by the vertical angle theorem, those two are congruent. So now if we apply the transitive property of congruence, okay, if angle 1 is congruent to angle 4 and angle 4 is congruent to angle 5, then angle 1 is going to be congruent to angle 5. And this is by the transitive property of congruence. Notice that it does not say equality. Equality is only for numbers. So now, well, what is the relationship between 1 and 5? 1 and 5 happen to be corresponding. So if the angles are corresponding and congruent, that implies that G and H are going to be parallel. So G is going to be parallel to H because of the converse, okay, of the corresponding angle theorem. So you see, we are applying the converse. So how did I apply it? Well, think about this. Angle 1 and 5 are corresponding, and they're congruent. By the converse of the corresponding angle theorem, those two lines are going to be parallel. And that is example number 2. Let's look at example number 3 now. Okay, here's example number 3. It says in the diagram, R and S are parallel. And angle 1 is congruent to angle 3. So here's the thing. We got to annotate when things are congruent. So here, they tell me that angle 1 and 3 are going to be congruent. And I have to show that P and Q are going to be congruent, not congruent, but parallel. Now, what they do tell me is that R and S are going to be, parallel. Okay, so what are we going to do? So if you look, okay, if you actually kind of ignore this line right here, you see that those two lines right there are parallel, cut by a transversal. So the relationship between angle 1 and angle 2 is that they're corresponding and congruent. So angle 1 is congruent to angle 2. And why? What's the reason? Because of the corresponding angle theorem. Okay? Now, I just realized this is actually needs to be a proof, but we're just going to do not a 2-column proof, but just like a paragraph proof. So angle 1 and 2, they're corresponding angles, okay? And they're congruent. Now, we also knew that angle 1 is congruent to angle 3. That was given. So by the transitive property, we can state that angle 2 is congruent to angle 3 by the transitive property of congruence. Okay, so here's the thing. If I were to put a little line like that, okay, if 2 and 3 are congruent and they're also alternate interior angles. That will imply that both P and Q are going to be parallel. So we can state that angle 2 and angle 3 are alternate interior angles and congruent. Okay, so therefore lines P and Q must be parallel. So P is parallel to Q by the converse, okay, by the converse of the alternate interior angle theorem. It's a little paragraph proof. Sometimes it's kind of fun to do one of those. Okay, so this is example number 3. Let's look at example number 4. Okay, in example number 4, you have the flag of America. Okay, now the flag of the United States has 13 alternating red and white stripes. Now guys, I don't have a color printer, so our red stripes are actually black. Okay, each stripe is parallel to the stripe below. Explain why the top stripe is parallel to the bottom stripe. So here's this. We know that stripe 1 is parallel to stripe 2. Okay, we know that stripe 2 is parallel to stripe 3. So by the transitive property of parallel lines, stripe 1 is parallel to stripe 3. We know that stripe 3 is parallel to 4. 4 to 5, 5 to 6, 6 to 7, 7 to 8, 9 to 10, 10 to 11, 11 to 12, and 12 to 13. So I can keep on going and apply the transitive property like 11 times, and then that's going to show me that the first stripe is going to be parallel to the last stripe. Okay, so you can say that you can apply the, I believe it's called the transitive property of parallel lines. Okay, I can't remember how many times, like 12 times? 12 times. All right. Now don't forget, make sure that you guys are doing your extra practice, and your extra practice happens to be all on page 80. Have a good day.